Here's a strange fact to start with. 40 degrees below zero is the one temperature where Fahrenheit and Celsius actually agree with each other. -40 is -40, no matter which scale you're using. It's also roughly the temperature some Ice Age humans faced on an ordinary winter night. Not a freak storm, not a rare cold snap, just Tuesday. At that temperature, exposed skin can start to suffer frostbite in minutes. Your body burns through energy just trying to keep your core warm enough to keep your organs functioning. And there was no thermostat, no heated car, no goose-down jacket waiting on a hook by the door. So how did anyone survive this, let alone raise children, hunt, and build entire societies through it? The answer isn't one clever trick. It's an entire survival system, stacked in layers, each one solving a different piece of the same brutal equation. Your body is constantly losing heat, and if it loses more than it makes, you die. Everything Ice Age humans did, every shelter, every stitch of clothing, every meal, came down to managing that one equation. Let's start with the ground itself, because before you can even think about staying warm, you need somewhere the wind can't reach you. Across huge parts of Ice Age Europe and Asia, in a landscape scientists call the mammoth steppe, there were almost no trees, no caves in a lot of these regions either. So people built shelters by digging down into the earth itself, creating what archaeologists call semi-subterranean pit houses. Even a few feet of soil provides real insulation, shielding a sleeping body from wind chill that could be lethal within the hour. At a site called Mezerich in modern-day Ukraine, archaeologists uncovered something remarkable. The remains of dwellings built from the bones of dozens of mammoths. Skulls stacked into a foundation, tusks curved into doorways, the frame then covered in hide, creating a dense, windproof shell. These structures, dating back roughly 15,000 years, weren't decoration or ritual. They were engineering. A wind barrier and a heat trap built from the largest available material on a landscape with shelter stopped the wind, but the moment you stepped outside it, your survival came down to something much more personal, what was actually touching your skin. This is where the story gets genuinely impressive. At Sungir in modern-day Russia, archaeologists found burials dating back around 30,000 years, containing thousands of small ivory beads. When researchers mapped exactly where those beads had fallen relative to the skeletons, a pattern emerged. The beads lined up in rows consistent with fitted garments, sleeves, trousers, even soft-wrapped footwear. This wasn't a hide thrown loosely over the shoulders. This was tailored clothing, built in layers, designed the same way a modern parka is designed. A base layer against the skin, insulation in the middle, and a windproof outer.
And that kind of clothing requires a tool most people don't associate with the Ice Age: the needle. In Siberia's Denisova cave, researchers uncovered a needle carved from bone with a tiny eye deliberately drilled through one end, estimated at around 50,000 years old, among the oldest sewing tools ever found. Making one by hand, using only stone tools, would have taken real patience and real skill. That single invention changed everything. Instead of draping fur over your body, you could now shape it, seal the seams, and trap a layer of warm air directly against your skin. Some researchers believe this leap in clothing technology may partly explain why certain groups of modern humans were able to push into colder territory than Neanderthals ever did. Warmth, engineered by hand, one stitch at a time. Here's something people rarely think about. Staying warm in extreme cold isn't just about what you wear, it's about what you eat, and just as importantly, what you don't eat. Your body generates heat by burning fuel, and not all fuel burns the same way. Fat is extraordinarily calorie-dense, and metabolizing it produces a steady, sustained release of energy, exactly what's needed to keep a body warm through a 15-hour winter night. Lean protein alone can't do this job. In fact, explorers and Arctic researchers have long documented a condition sometimes called rabbit starvation, where a diet of only lean meat with no fat at all leaves the body malnourished and struggling, no matter how much of it you eat. Ice Age humans appear to have understood this instinctively, even without the biochemistry to explain it. Bone marrow, in particular, was treated as a prized resource. Archaeologists can actually identify this in the fossil record. Ancient animal bones cracked open in distinctive patterns, consistent with deliberate extraction rather than scavenging leftovers. Nothing with calories in it went to waste. That fat had other uses too. At several Upper Paleolithic sites, archaeologists have recovered small carved stone lamps, some still holding residue believed to be animal fat, used as fuel for a controlled flame, lighting the inside of a shelter separately from the main fire. And when it came to storing food long term, the frozen ground itself became a natural freezer. Groups dug storage pits into permafrost, preserving meat for weeks without it spoiling, essentially building refrigeration thousands of years before electricity existed. So far, everything we've covered is technology, shelter, clothing, food. But there's one more layer to this story, and it's built directly into human biology itself. When your body gets cold, it doesn't just sit there. Blood vessels near the skin's surface constrict, a process called vasoconstriction, pulling warm blood away from your extremities and concentrating it around your vital organs. Shivering kicks in, rapid muscle contractions that generate heat as a byproduct. And humans also carry something called brown adipose tissue, or brown fat, a special type of fat whose entire biological job is to burn energy and produce heat directly, without any shivering required at all. There's also a broader pattern researchers have long studied in human body shapes across different climates, generally described through what's known as Bergmann's and Allen's rules. Populations adapted to colder environments tend, on average, to carry a stockier build and shorter limbs, a body shape that reduces surface area relative to volume and therefore loses less heat. Some researchers believe Neanderthals, who lived through extraordinarily cold periods across Ice Age Europe, may have carried an especially pronounced version of this build. And some geneticists theorize that certain cold-related traits still found in modern human populations today may trace back to interbreeding with Neanderthals, though exactly which genes did what remains an active area of ongoing research. None of these systems worked alone. The shelter reduced how much heat you lost to the wind. The clothing trapped what your body made. The fat-rich diet supplied the fuel to keep making it. And underneath all of it, biology itself was quietly doing its own work, tightening blood vessels, triggering shivers, burning brown fat, just to keep one fragile, mostly hairless primate alive through nights that should have killed it in hours. So the next time you complain about a cold morning walk to your car, remember, somewhere back in your ancestry, people survived actual 40 below nights with nothing but bone, fur, fire, and a body that simply refused to give up. That's not just impressive. That's the reason any of us are here to complain about the cold at all. Let me know in the comments which Ice Age survival trick surprised you the most. See you in the next one.